write down the equations that we're going to use. There are two equations. The first is the focal length equation, 1 over f equals 1 over do plus 1 over di. And then the other equation, magnification, equals hi over ho equals negative di over do. The classic Snow White song, Hi Ho Dido. You all know it. Yep. All right. Locate the image of an antelope that's placed 30 meters above the lens, or from the lens. So the first thing we need to do is write down all the knowns and unknowns, which it only gives me 2 for starters. It gives me the focal length of 10. It gives me the image, or locate the image for an object 30 meters away. So it tells me f for the focal length is 10 meters. And it tells me do for the object is 30 meters. And those are the only 2 numbers it gives me. So now I need to know what I'm solving for. Well, I'm solving for the image distance, how far away it forms from the lens. I'm solving for the magnification. And I'm solving for hi, the height of the image. So, first thing we need to do is we need to find the image distance. We need to find di. So, I look at my equations at the top here and I say, oh, they both got di. That's a bit of a problem. So now I go through and I say, which equation has what I know already? This has do, I know it. This has f, I know it. So I'm going to use that first equation, 1 over f equals 1 over do plus 1 over di. Now, there are 2 ways to solve this one. The first way is to use fractions. The second way is to use decimals. Some of you swore off fractions and said, I'm never going to use fractions again in my entire life. All right, sweet. You can do decimals if you want to. Honestly, I think fractions are easier. But it's up to you. All right. I need a common denominator between 10 and 30. Luckily, the common denominator between 10 and 30 is 30. So what do I need to multiply the bottom by in order to get 30? Well, 10 times 3 is 30. Okay? Now, the top is like a jealous sibling. If you get one thing, they got to get the same thing. So if I did 3 to the bottom, I got to do 3 to the top. That makes this 3 over 10 equals 1 over 30 plus 1 over di. I'm going to subtract 1 over 30 to both sides. This becomes 2 over 30 equals 1 over di. And you might be saying to yourself, Mr. B, this 1 over business is making me have a heart attack. I don't want to deal with it. Well, okay, let's not deal with it. Flip the top and the bottom on both sides. So 30 over 2 equals di over 1. 30 divided by 2 is 15 equals di. Problem over. There you go. That's all there is to it. Yes, sir. Why is the, say one more time? Because I wrote the wrong thing. Thanks. It's 3 over 30. Good. Now, some of you are like, oh my gosh, fractions happened, and I swore to myself I would never do fractions again. Okay, don't do fractions, do decimals. 1 divided by 10 is 0.1. 1 divided by 30 is 0.033 plus 1 over di. Subtract 0.033. And that gives you 0.67. Oh, 0. Wait, hold on. Let me get my numbers right. Yeah, 0.067. Equals 1 over di. Now, you can't have 1 over di as the answer. Okay? Got to be di. It's got to be di over 1, not 1 over di. And you can't just flip this one like you did the last one because there's nothing to flip on the left side. So what you have to do is multiply both sides by di. That gives me 0.067 di equals 1. Now I need to divide by the 0.067 to get the di by itself. And when you do that, you get di equals 14.9. We had to round, so it's not exactly the same answer, but it's pretty darn close. Okay, I'm going to show you a shortcut on how to do this one, an easier way to do it. When you get to this point, 0.067 equals di, you can use your calculator to do the rest of the steps. So on your calculator, there's either going to be a button that says 1 over x, like this, or a button that says x negative 1, like this one. All you have to do is that. You just hit that button and it'll do it for you. So 0.067 14.9. Okay, here's that on the other calculator, 0.067. Here's the 1 over x button, 14.9. So just a shortcut way to do it on your calculator if you want to save yourself some time and you're doing it the decimal way. All right, we're done with part A. Put a little check mark to feel good about myself. Okay, I got good news. The rest of them are much easier. So now I need to find the magnification. Well, there's only one equation for magnification. It's this one. M equals hi over ho equals negative di over do. And I know what you're thinking. You're thinking, Mr. B, what's going on with these double equal signs? Here's what's going on with them. You pick one, you ignore the other. So I have di, which I just found, and I have do, which was given to me. So I'm going to ignore the hi and the ho. I'm just going to pretend they're not even there. And I'm just going to write m equals negative di over do. That's it. That's it. So what is di? 15. But the negative is in front of the di, so it's negative 15 over do, which is 30. So the magnification is negative 1/2, or 0.5. That's it. See? Told you it was easy. All right, last math part. Find the magnification. Oh, sorry. I wrote the wrong thing. Good job, me. I didn't mean to find the magnification. I meant to find the height. Not find the magnification. Find the height. That's my bad. Find the height of the image if the antelope is 2 meters tall. Okay? So, we're trying to find the height of the image, but it says that the object, the antelope, is 2 meters tall. So that tells me that HO equals 2 meters. So there's only one equation that's got height in it, and that's this one. So I just use the DIDO, so I can ignore them now. And I just use M equals HI over HO. So M is -1/2 equals HI over HO, which is 2. Multiply both sides by 2. HI equals -1. That's it. Okay, done with C. Last step. We got to determine if it's real or imaginary. And this is the easiest step of all. You flip over to your back page, or not to the back page, sorry, you flip over to your front page, and you read the thing that says sign of M. Positive sign of M means it's right side up and it's virtual. Negative sign of M means it's upside down and real. So I go and I look and I see a negative sign for M, which means it's upside down and real. So all you have to do is write down real, and you should be able to explain your reason. And the reason this one is real is because the magnification is negative. Thank you. That's all there is to it. So the first solving is usually kind of tricky. You have to be careful on that. But after that, it gets pretty straightforward. And it's just working through the equations. So for the practice, you can skip number 1 for now. So write skip next to it. You're just going to do 2, 3, and 4. Number 2 is just like the example we did, except it's diverging, which means the focal length is negative. So that'll change things. Number 3 is a converging lens, where I give you some different numbers. And number 4 is going to work in a different direction, because for number 4, I give you heights instead of focal lengths. So that's a little bit different too.